Okay guys, welcome to lecture number 6. We're going to talk today about Riemann sums and some properties of definite integrals. So before we get to the Riemann sum part, I want to kind of give you some basic properties of definite integrals. And before we go any further, a definite integral, as you learned in pre-cal, is the area under a curve between the curve and the x-axis and in between two x values. Okay, so if I draw a function here, I just want to show you a couple of properties, and I'm going to try to do that using a picture. So let's say that we have the two x values a and b, and then we have some function that goes from a to b. Okay, well let's say that I wanted to find the area in this first property, the integral I should say, from a to a of f of x. Well, if I just try to find the area from a to a, I haven't really gone anywhere on the x-axis, and so I haven't accumulated any area if I just travel on the x-axis from point A to point A. So because of that, anytime we have an integral that have the same bounds as the lower bound and the upper bound, the answer is automatically going to be 0. So that's the first thing that you should know, is that anytime the bounds are the same, we just say that the integral is equal to 0. Okay, the second property is kind of what's called an additive property of definite integrals. And so what that basically means is that if I put a point in between a and b on here and call it c, then basically what we have is we have the area from a to c, which is right here, plus the area from c to b, which is right here, is really just equal to the entire area from a to b. So the way that we'll write that as a property is the integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. And so this one is represented by the blue up there, and the second term in this addition is represented by the red area up there. And so I can split that into two integrals by taking some point in the middle of a and b. Okay, and then the final property that I want to show you is a way that we can switch the bounds if necessary. And so basically this area is what's called a signed area. Okay, meaning it is either positive or negative. And I know you've grown up thinking that area is always positive. And in some cases that's true. But when we talk about definite integrals can be negative. And so basically what happens is that if we integrate from left to right, so for instance from A to B, we consider that to be positive area as long as it's above the axis. And right now we're just kind of talking about positive functions only. And so if I integrate from left to right, that is a positive area. But if I integrate from right to left or backwards, that is considered to be a negative area, again, as long as you're talking about a function that is above the x-axis. So because of that, our final property, if we want to switch the bounds of integration to instead say the integral from b to a of f of x dx, then what we need to do is we need to put a negative sign in the front. Okay, so I believe you have a couple of problems on your assignment that will utilize these properties, so I want to see if you can figure those out given the properties.